Hello everyone, and welcome to our 7.3 notes, Conditions of Parallelograms. So what is a condition? A condition is just going to be a way to prove that a quadrilateral, a four-sided shape, is a parallelogram. So if we have some unknown figure that is sketched or drawn, and we want to know, is it a parallelogram, yes or no? If we were not told it's a parallelogram, there are going to be 6 conditions that we're going to look at that will immediately, boom, instantaneously prove that a shape is a parallelogram. Okay, so 5 of them are going to be somewhat familiar to you because they're very similar to the properties of parallelograms, and that's going to be number 1, 2, 4, 5, and kind of sort of 6. We kind of looked at that a little bit. The newest one is going to be number 3. But let's review this. There are 6 conditions or ways to prove that a shape, a quadrilateral, is a parallelogram. Okay? The very first thing I want to focus on is that it says this word both. Okay? Both pairs of opposite sides are parallel. So just like by definition of a parallelogram, if you have both sides marked as parallel to each other, two different sets marked as parallel, then you can say immediately that it's a parallelogram without knowing any other information. Any of the other properties have to hold true, but if you have that in the picture, immediately know that the quadrilateral is a parallelogram. Okay? Another one of those things that has to have both is both pairs, again, of the opposite sides are congruent. So again, it has to be those two things, not just one set, but 2 sets being congruent, then immediately know it's a parallelogram without even knowing any parallel markings. If you see a quadrilateral and the opposite sides are marked as congruent, it is immediately a parallelogram. Okay, here's what's a little bit new. If you have one pair of opposite sides congruent, so that's this piece right here, these little tick marks, and then you also know that they're also parallel, that same set is parallel. So I'm going to change that to the little arrow. That same set has to be parallel and congruent, then immediately it's a parallelogram. Okay, so they have to be on the same side. So like on this picture, that's our top and our bottom set. You could also have that same information on the left and the right set. So another way that this could be pictured would be if it was on this one. So 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. So now you can see that in this picture, we have both sets. Oh goodness, we have both sets still marked as both congruent and parallel. So it doesn't have to be the top and bottom set. It can also be the left and right set. But notice that those are on the same opposite side set. Okay? All right, just like we talked about before with the properties, if it's a parallelogram, then the diagonals bisect each other. The converse is also true. If the diagonals bisect each other, then it's a parallelogram. So let's look at that. That just means that this point right here is the midpoint. These diagonals cut each other in half. So notice I've got a single tick mark and a single tick mark, shows that that's the midpoint of this diagonal getting bisected, and then a double tick mark and a double tick mark shows that those diagonals are cutting each other in half. Okay? All right. Again, this is going to be familiar to you. If we know that both pairs of opposite angles are congruent, so this set is congruent, as well as this set being congruent, if the opposite angles are congruent in a quadrilateral, immediately know it's a parallelogram. All right, this is the one I said is kind of close. If you have one angle that is supplementary, meaning adds up to 180, with both of its consecutive angles, that is enough to say that it's a parallelogram. So let's pause right there. What does it mean to be supplementary? That means that those add up to 180 degrees. So this is actually very, very close to number 5, but instead of having all 4 angles immediately, if you only have 3 of them, what happens here, we learned something called the congruent supplements theorem that says if you have this one blue angle that is supplementary to both this green angle and this green angle, that means that both of those must be congruent to each other. Those 2 greens by the congruent supplements theorem are congruent. Then there's one set of opposite sides. And then if you think through it as being a quadrilateral has an interior angle sum of 360. So 360 minus 105 minus 75 minus 75 is going to give you a total of 105 left. So what ends up happening is this little dot angle ends up being 105 degrees as well, and then this turns into condition 5. It's just a little bit more work to do. So it's essentially what they're doing is they're saving you time and saying you don't have to check the math. If 105 is supplementary to its next door neighbor, its consecutive angle 75, as well as the one on the other side, then this is going to be a parallelogram. Okay, so here's what we're going to do. We're going to work through a few of these problems. I'm actually going to start on the right and go to the left side because this first one, in my opinion, is one of the hardest. So I'm going to build up to that. Determine if each quadrilateral is a parallelogram, yes or no. If it is a parallelogram, indicate which condition above justifies your conclusion. So we're just going to say numbers 1 through 6. So let's start with this one. This one right here is a little bit deceptive because it's got diagonals. So which of my properties looks like a diagonal pictured? That is going to be property 4, which says diagonals bisect each other. That's my condition, okay? So we don't have anything else marked. We have no parallel lines, but it says if the diagonals bisect each other, then this quadrilateral must be a parallelogram. It's a way to prove it. Well, right now I have a single tick mark here. Where's the other tick mark that's single? Right here. Here's the problem. This one, this purple one, is not the same length as this yellow one. So those diagonals are not bisecting each other. And so unfortunately, this is going to be a no, and we're just going to leave this blank. Okay, there is no condition that proves this a parallelogram because it is not. Okay, let's go to this one right here. We've got angles pictured. What kind of angles? We've got opposite angles pictured. So 115 is congruent to 115, and 65 is congruent to 65. Since we have both pairs of opposite angles congruent, this shape, this quadrilateral, is going to be a parallelogram. What property justifies that? That is going to be number 5, which says both pairs of opposite angles are congruent to each other. All right, let's look at this shape. In this shape, we've got two things happening on one side, which is a good sign. We've got one set of of opposite sides congruent, and that same set is also parallel. So which property is that? This is going to be a yes. Notice that those are happening on the exact same set of opposite sides. That is going to be our number 3. That one pair of opposite sides are congruent and parallel. So we've got both here, congruent and parallel. Okay. All right, this is a lot going on. So when you first look at this picture, it looks like we've got one set of opposite sides, or opposite angles, one set of opposite angles are congruent to each other currently. And then we've also got these angles marked as congruent, but those are not opposite angles in this shape, in this quadrilateral. Right now, those are what we call alternate interior angles. This is my transversal happening right here, and those are alternate interior angles. So here's what happens. We are able to say that these green lines must being parallel to each other. So these end up being parallel to each other because if alternate interior angles are congruent, then those lines must be because of these pink alternate interior angles. We are able to say that those lines must be parallel, okay? Because these two star angles were congruent to each other. That's what allowed us to say that the lines were parallel. Okay, so right now we only have one set of opposite angles congruent to each other, and then we have one set of opposite sides parallel to each other. So there's a few different ways to approach this problem. How I would look at this is two triangles put together. We have this overlap happening, this reflexive property, saying that this side in these two triangles, triangle 1 and in triangle 2, that side is overlapping and that side is congruent to itself. And so we're able to say that these two triangles are congruent to each other. Triangle 1 is congruent to triangle 2. How do we know that? By angle, angle, side. That's a throwback to last semester. By angle, angle, side, these triangles are congruent. And if those triangles are congruent to each other, then we're able to say that this side is congruent to this side by CPCTC. Corresponding parts of congruent triangles are congruent to each other. And now we have one pair of opposite sides that are both congruent and parallel. So this is a yes by number 3. So you can see why that one takes a little bit longer. It's not just as direct and as immediate as these other problems we've done so far. So that was a lot going on, but we had to prove the triangles congruent to each other. And so just a little bit of extra work there. All right, now we've got some letters. This makes this a little bit easier. Okay, so angle A is X. Angle C is also marked as X. So even though I don't know what they are, I know that those are both going to be congruent to each other. Angle B is 2Y. Angle D is also 2Y. So no matter what Y is, those are going to be congruent angles. So what do I have? This is going to be a yes because the opposite angles are going to be congruent to each other, both pairs of opposite angles. So that's going to be number 5. Number 5. All right, you can see why I put this one under this one. We have something that's almost identical. We've got a set that is parallel, and then we've got a set of opposite sides that are congruent. But notice that those are not happening on the same thing like they were before, on the same set. And so this has to be a no. This is a no because I don't have two pairs of opposite sides that are parallel. I don't have two sides of opposite sides that are congruent. I only have one set of opposite sides that are parallel and then a different set that are congruent. And because those are not happening on the same one, those are happening on different lines, that is why that's going to be a no. Okay, MNQP. I've got diagonals, so let's check and see, do the diagonals bisect each other? This set right here, whenever this MP goes through QN, it does bisect QN because I've got those markings. This one has expressions. This is interesting. This one says 2x, and then this one says 10x minus 3. Okay, so this is going to be a kind of sort of maybe question. If 2x is in fact equal to 10 minus 3x, then this is going to be a yes. If not, it's going to be a no. So let's find that value that would make this a yes. So we add 3x to both sides. We get 5x equals 10. So we're going to say yes if x equals 2, then it's going to be a yes. That would be the diagonals bisect. Which one is that? That's number 4. That's condition 4. It would be no if not. Okay, if x was anything else, if x was 3 or 2.5 or anything else, it would be a no, but it would be a yes if x is equal to 2. Okay. All right, let's see. We have two things happening on the same set of opposite sides. So let's make sure it's both parallel and congruent. Here's the parallel mark that I need. This does not have a congruence mark, but it does say 30 meters, so I'm able to add that because this one's also 30 meters. So this is a yes by condition number 3. One's pair of opposite sides is both congruent and parallel. All right, we've got an opposite pair of angles that are congruent and another pair of opposite angles that are congruent. So that one is immediate yes. Which condition is that? Opposite angles congruent. That is condition number 5. Okay. All right, again, another sneaky one. I want you to pause it and see if you can figure this one out. This one has a single mark here and a single mark here. Well, those are consecutive sides, not opposite sides. It's got 2 tick marks here and 2 tick marks here, so this is actually a no. We don't have opposite sides, 2 pairs of opposite sides that are congruent. We have consecutive sides that are congruent. All right, on this one, we've got this angle marked congruent to its opposite angle. We've said this is 100 and this is 100, so I'm actually able to add those congruence marks. And so this is a yes. Which condition is that? Opposite angles being congruent. That's going to be number 5. Number 5. All right, we've got diagonals happening, so I'm thinking it's going to be number 4, but let's make sure. Let's make sure that these are actually bisecting each other. 4 and 4, so that is the midpoint. Those are congruent. And then 6 on this side and 6 on this side. So those diagonals do, in fact, bisect each other. So by number 4, this is going to be a yes. This quadrilateral is a parallelogram. Without knowing anything else, I know that for sure it's a parallelogram without opposite sides marked as congruent, without parallel lines. Because the diagonals bisect each other, I immediately know that it is a parallelogram. All right, this next set just says solve for the variable that makes the quadrilateral a parallelogram. So that's similar to this one right here that we did up here, where we found the value that would make it a parallelogram. We're doing that on these problems. Okay, so we've got some angles marked on here. We've got all 4. So if this is 114, x would also have to be 114 in order to say that this is a parallelogram. And then if this is 66, y would also have to be 66. So let's fill that in. If x is 114, and then if y is 66. If y is 66 and if x is 114, then that's a parallelogram. If not, it's a no. It's not a parallelogram. Okay? Now we've got opposite sides. If y is equal to its opposite side, which is 9, then it's a parallelogram. And if 16 is equal to its opposite side, which is x, then it's a parallelogram. So if those values hold true, for y that would have to be, for x that would have to be 16, and for y that would have to be 9. So I need to change those colors. Hold on one second. Fix that. If x is equal to 16, that's the blue one, then it's a parallelogram, and then if y is equal to 9. Okay? All right. If not, it's not a parallelogram. So what would make this quadrilateral a parallelogram? We've got our congruence marks on the diagonals so far for one set, but this 4x plus 2 would have to be equal to this segment 5x minus 6. So let's find that value. If 4x plus 2 is equal to 5x minus 6, then 1x is going to be equal to 8. If x is equal to 8, it's a parallelogram. If not, then the quadrilateral is not a parallelogram. Let's plug it in and check it. 4 times 8 plus 2 is going to be the same thing as 5 times 8 minus 6. Okay? All right, last but not least, again, I have one set that has 2 markings, which is good news so far. one set of these little triangles, that means that those lines are for sure parallel. How do we make sure that they are also congruent? Well, we would have to see if 2x plus 3 is equal to x plus 7. So if that is in the case, let's find the value of x that would make that possible. We'd move our x's to the same side, and we get 1x over here. We'd subtract 3 from both sides, we get x is 4. Let's double check our math. 2 times 4 is 8, plus 3 is 11. What did I do wrong? 2 times 4 is 8, plus 3 is 11. And so 7 plus 4 is also 11. Okay, so yeah, if x is 4, then these are both 11. Then that one set of opposite sides is both parallel and congruent. Okay, so on the back is your homework. We've got some practice problems, and we will check that tomorrow.